In this video, we're going to start with number 42. So 42 is asking us to solve this equation. On this one, they don't give us any restrictions between 0 and 2 pi. So I'm going to solve this for all solutions. And so I'm going to start by subtracting over my 1 and dividing by my 2. So that'll be negative 1/2. So what we're looking for here is where is cosine negative 1/2? So we talked about our function restrictions in another video. Cosine uses these, so I'm going to look over here in the second quadrant where cosine is negative, and I know cosine is 1/2 at pi over 3, so in the second quadrant I'm going to call that 2 pi over 3. Now when we talked about equations with cosine, we said we have two answers, a positive and a negative, and we need to add 2k pi. So don't forget to go back and look over all of your rules about solving equations. All right, on 43, we start off with sine cubed x is equal, is equal to sine x. So I'm going to start by moving that sine x over to the left by subtracting it over. All right, then I'm going to take out a common factor of sine, and that's going to leave me with sine squared minus 1. Now a couple of different options here. You could take this and set it equal to 0 and use a square root. Don't forget to use your plus or minus on that. Or we could factor this again as a difference of two squares into sine x and sine x. And one gets a plus 1 and one gets a minus 1. So just the opposite of the difference of two squares, foiling those together, that's how we factor it. All right, so let's take that sine x and set it equal to 0 as well as both of these. Alright, so I'm going to take on this one my inverse of sine at 0. So I know I have sine values of 0s and 1s on my quadrantals. Let me go ahead and fill those in. So first I'm looking for where sine, which is y, is 0. And that's going to be right here at what I'm going to call 0 pi, or you could call that just 0 if you want to. And with sine we have two answers and 2k pi's. And to find the second answer for sine, we subtract from pi. So pi minus 0 still just gives us pi plus 2k pi. So I get both answers there where sine is 0. Here's the other one right here. All right, on this one, I'm going to take the inverse of sine and I'm going to subtract over my 1. So the only place where sine is negative 1 is going to be down here. I'm going to call that negative pi over 2 because it didn't tell me just to solve between 0 and 2 pi. So I'm going to use those function restrictions. And then if I subtract from pi on this one, I get a minus and negative there that's going to turn into a plus, and I get a common denominator gives me 3 pi over 2. And 3 pi over 2 and negative pi over 2 are really the same thing. We don't need to list both. Finally, I'm going to do the inverse sine of 1. And so my sine value is 1 up here at pi over 2. And again, if I subtract from pi on that, pi minus pi over 2, still just pi over 2. So that'll be my only answer for that one. Don't need to list them twice. They all get that plus 2k pi so that we found all solutions. Okay, on 44 we start talking about our sum and difference formulas. So this first one tells me to use the sum or difference formula to find pi over 12. So I can use a lot of different angles to do that, but I'm going to have to be subtracting because I've just got 1 pi over 12. So I'm going to use 4 pi over 12 minus 3 pi over 12. You could use 3 minus 2 if you wanted to. A lot of different options, but make sure that you use two angles that are on the unit circle. So that's going to give me pi over 3 minus pi over 4. Again, lots of different options on that one. All right, so my difference formula for sine, which is right here, these are the formulas that this is one of the formulas that we'll give you on the test. And so I'm going to use that one right there. So I'm going to use sine, cosine, minus cosine, sine. And I like to put some parentheses down here and fill them in however I want to. So I'm going to fill in my pi over 4s first because I'm working in the first quadrant where everything is positive. So I know both sine and cosine are going to be the square root of 2 over 2. And then when I'm working at pi over 3 in the first quadrant, I know I'm going to be positive where cosine is 1/2 and sine is the square root of 3 over 2. So now I'm going to work with my fractions there and just multiply top times top and bottom times bottom. So that's going to give me the square root of 6 over 4, and over here the square root of 2 over 4. And with that common denominator, we'll just go ahead and put that together as the square root of 6 minus the square root of 2 all over 4. Okay, remember that we can also check these on your calculator. So with the sine of pi over 12, I need to make sure that we're in radian mode first. And so I'm going to put in the sine of pi over 12. And then I'm going to put this in right here with alpha f1 number 1 for my fraction. If you don't have that option, you can put these in just separately. Square root of 2, and I'm going to divide all of that by 4. And those answers should come out to be exactly the same. And they did. Good way of checking your answer on those. Okay, on 45, we're still working with our sum and difference formulas here, but this time we're working with something that we can add together to be able to get. So let's see here. I'm going to work with a tangent of 75 degrees. What you want to be careful of, though, on this one is with tangent, you want to try to avoid your pi over 6 angles, which is the same thing in this case as 2 pi over 12. Let me start by changing this 75 degrees into radians, and so I'm going to change that into 5 pi over 12. That's really what we're looking at there with that 75 degrees. So again, not really wanting to use 2 pi over 12, I'm going to try to avoid doing 3 plus 2, and I'm going to subtract instead. So you have that option. So to get to 5, I'm going to use 8 pi over 12 minus 3 pi over 12, which then on my unit circle, that's going to give me 2 pi over 3 minus pi over 4. And now I've avoided using an over 6 type angle. With a tangent question, that's going to give you an extra headache if you use a pi over 6. All right, so let me fill that into my tangents difference formula. So 2 pi over 3 minus the tangent of pi over 4. And then I'm going to divide that by 1 plus these two things, same values, multiplied together. All right, what we want to be really careful of here is that 2 pi over 3 is in the second quadrant where tangent is negative. So it's going to give me negative square root of 3 minus 1 on the top. And then on the bottom, I'm going to have 1 plus negative square root of 3 times 1. So that's going to give me negative square root of 3 minus 1. And on the bottom, I'm going to have 1 minus the square root of 3 because I'm going to make that plus and negative become a minus. All right, this is where we use that conjugate to get rid of the square root in the denominator. So I'm going to keep my two terms exactly the same, and I'm going to change the sign that's in between them. And then I'm going to multiply by exactly the same thing up there on the top. So on the top, when I multiply, that's going to give me negative square root of 3. This is going to give me minus 3. This is going to give me minus 1. And this is going to give me minus the square root of 3. Then on the bottom, the middle term should cancel out. And that's really what we need to happen. So I'm going to do my first, which gives me 1. My outside would give me the positive square root of 3, and then the negative square root of 3. And then this right here is going to give me minus 3. And so up there on the top, I've got negative 4 minus 2 square roots of 3, all being divided by negative 2. And since that negative 2 can go into both, I'm going to go ahead and let it. So that'll give me 2 plus the square root of 3. And just like that last one, I can check this in my calculator. So since we know both radians and degrees, you can do it either way. It's your choice. Let's see here. If I'm working in radians, I'm going to do the tangent of 5 pi over 12. Or if